Hello everyone. So I'm going to talk about basic mechanical engineering subject. So in this lecture video, you have unit 3. The unit 3 we have topics like power plants, power transmission and robotics. So this is the syllabus for basic mechanical engineering. So unit 1, this is unit 2. So now we are going to talk about unit number 3. So these are all the syllabus content we are going to discuss. So here first we are going to talk about the power plant. So before going to discuss the power plant, I want to give some prerequisite. I think the pictures what I'm showing, so you might be already seen in your school age, right? So this is like a bicycle dynamo. It will be engaged with the tire like this. Whenever you are riding the bicycle, this dynamo head it will rotate. While rotating, this mechanical energy it is converted into electrical energy. That electrical energy it is tapped through the wire and you will get the lighting. So this is what the simple thing. And similarly, here you have a graphical representation. If you look at what is there inside the dynamo, you have two things. One is coil and second one is magnet. Magnet you have north pole, south pole, both are there. This is the dynamo head. So this will be engaged with the tire. Whenever tire rotates, the magnet will rotate within the coil. So according to Faraday's law of electromagnetic induction, your coil and magnet, if there is a relative movement between these two, EMF is generated. So the generated EMF it is tapped out, and so it is helping us to light a lamp. So this is the uh, bicycle headlight for us. So while studying in elementary school, I used to have this. We have to ride villages. We don't have any electric post, right? We don't have light. We use this light headlight, bicycle headlight, and we will ride. So with this prerequisite, I will go. So now what you need to understand is power generation, right? Using a small dynamo generating one small light for a bicycle headlight, it is a concept of power generation. Similar thing if you are going for larger scale, how it will be, right? So ultimately here we need to clearly understand that a coil and a magnet, if you are providing relative movement between these two, EMF is generated. If it is a smaller one, you will get a few millivolts EMF is generated. Whereas in case of big power plant, it will be like up to megawatts level power is generated. Now we have many topics. One of the topic is the thermal or steam power plant. Thermal or steam power plant. So thermal power plant means this. I am from Tamil Nadu. I know the NLC Neyveli Lignite Corporation. They have a thermal power plant is there at Neyveli near Chidambaram. That Chidambaram I completed my PG course. Therefore, frequently I watched it. Two times I visited. Here, the thermal power plants, the power is generated through thermal process. Thermal means that is associated with the burning process. Generally, in thermal power plant, what they are doing means they are extracting the coal from the earth. Then they will do process, then burning the coal. After burning the coal, heat energy we are getting. Then heat they are converting into steam. That kinetic energy of the steam is used to rotate the turbine. Okay, rotate the turbine. That rotary movement again it will be rotary movement is provided to the magnet or coil. They are giving relative rotary movement that generate EMF. This is the simple concept. The difference between dynamo and here is dynamo. Your whenever tire rotates, the dynamo head is rotated. The dynamo head connected with the magnet is rotating within the coil. So therefore, you got the relative motion. Here, similar relative motion is generated from the kinetic energy of the stream. Here, the thermal means that coal is burned and it is converted into heat energy, that is a thermal energy. That thermal energy again further converted into steam. That the kinetic energy of the steam is utilized to generate the power. So, this is the basic principle of thermal power plant. Thermal power plant station is a power plant in which prime mover is a steam turbine. They are using steam turbine. Water is heated, turned into the steam, spins a steam turbine which drives the electrical generator. The coal is used as a major source of fuel. The thermal power plant works like a principle of Rankine cycle. Anyway, Rankine cycle it is not part of our syllabus. So just we look at the layout of thermal power plant. So if you take the thermal power plant, you have to start your work from here. Uh, Here you have a fuel. Fuel means coal. So coal it is extracted from the earth and processed, and here they are giving. The fuel is burned, and that fuel it is sending to boiler and economizer. You know the role of boiler. Boiler is a steam generator. So now burning process is happening. Now water is added. So therefore, what happened? Heat plus water converted into a steam. So that steam is generated. Then after generation of steam, again the high pressure steam it is going to turbine. The kinetic energy of the steam rotate the turbine, so therefore you will get the mechanical movement. Now you have to take example of dynamo. Here the kinetic energy, that high speed instead of mechanical movement, the high pressure steam which gives the rotary movement. So this is the alternator. You will get the three phase supply. So once the steam which is coming out from the generator, again it is condensed. Condensed means cooling. Here you have a cooling tower. The cold water is circulated, so that the cold water it will carry away the heat. Again condensate into water pump. Again they are high pressure heating they are giving. Then again boiler heat pump, low pressure. Again they are sending into boiler. So this is the one end. The fuel after burning, you will get ash. So we are burning the coal. While burning the coal, a lot of ash will come. That ash we are separated, and a separate ash handling unit is there that will be divided, disposed separately. While burning the coal, a lot of gas will come, smoke and gas will come. There, what they will do is they will extract the heat from the air. That heat it will be recirculated. So after extracting the heat, then again the gas, so that flue gas, it is escaped through the chimney. This drawback for the power plant nowadays, we have two important problem. One is the burning of coal, which emits a lot of that creates a lot of pollution. Yeah, there is a cause for air pollution. And another important thing is the ash depositing on the land. It is giving a lot of problem. And third one, it is very difficult to get the high quality fuel. We are extracting that we can't process. We can't. We are not getting quality fuel. So therefore, the coal is there, but the calorific value it is little less. So these are all the drawbacks for the thermal power plant. Next, I am coming to the principle and operation of thermal power plant. So already by using the layout, I clearly explained thermal power plant operate a principle of Rankine thermodynamic cycle. It is an idealized thermodynamic cycle of heat engine that converts heat into mechanical work. Mechanical work in the sense converted into heat. That heat again mixed with water, it is converted into a steam. That the kinetic energy of the steam that gives the mechanical work. That is rotating turbine, no, that is called mechanical work. The heat is supplied externally to a closed loop, which is usually uses water and working fluid. Thermodynamic cycle in which there is a net heat transfer to the system and net work transfer from the system. Here the power generation is from coal that can be estimated means calorific value. So this is what I said. We are extracting coal, but the calorific value it is not there. So if you get a high grade coal, we will get more. And nowadays, what happened? The low calorific value and more smoke is coming. That will give a problem. This we have to understand that steam turbine. I think people you have a doubt to understand the rotating turbine or something. Here there is a word available. What is called mechanical work. This is you can understand by a simple example. So while cooking, right, take water in a vessel and put one plate to cover the vessel and heat. Right, continuously if you are applying heat over the period of time, the pressure is increased, then kinetic energy of steam will increase. Over the period of time, the pressure increases automatically. The high pressure steam pushes the plate from the vessel. So that is called mechanical energy. Similarly, if you are burning coal, generating more heat input, more pressure will come. Therefore, that excessive pressure that rotates the turbine. This is the simple concept for the thermal power plant. Next, I am coming to diesel power plant. So, previous the here diesel and thermal power plant, the basic difference is there we are using coal as a working fluid. Here we are using diesel as a working fluid. I think this difference you might be understand. The children from 80s, you will understand. You will get the coal. The train is running by coal. After the deflection of fossil fuel, again they started to use the diesel engine. Then nowadays they are using electrical engine. Train they are using, right? The diesel engine when compared to coal, this emit very less fuel. Where thermal power plant fuel is in the form of solid, here diesel fuel is in the form of liquid. However, the same process, same burning the previously burning the coal, here burning the diesel. Again, we are generating heat energy, converting into steam. Then again, what happened? Kinetic energy of the steam it is utilized to deliver to provide the mechanical energy that helps as per the Faraday's law of electromagnetic induction. The you will get the power generation. So here, working principle of diesel engine. This is called the internal combustion engine. It is called IC engine. Internal combustion means inside the engine your diesel is burned. Diesel is combusted. Combustion means burning process. In IC engine fuel burn inside the engine and products of combustion from the working fluid that generate mechanical power. The working fluid undergoes repeated thermodynamic cycle. The typical thermodynamic cycle has following distinct operation. So this discussion we are going to see in unit number 2 also. First, the cylinder is charged, then cylinder contents are combusted. Charging means loading the fuel. Then your combustion compressed. Then again burning process started. Creation of high pressure, pushing the piston, expansion of product. Then exhaust spent product combustion to the atmospheric product. This also you have a emission problem like how we are the automobile we are using diesel as a fuel. The pollution which emits the pollution. Coming to the layout of diesel power plant, similarly here you have a uh, this is a simple layout. So this is almost like your diesel power plant means. Uh, in our college, if you look at that, just opposite to the first year block, you have a generator. So that is a small diesel power plant. Mini, almost it is called a mini power plant. There we are going to pour the diesel. Then this is called IC engine, right? Combustion ignition engine. There, fuel is burned, then heat is generated. From heat converted into steam. Then again, sometimes steam will generate. Otherwise, the hot gas, right after burning, high pressure hot gas, which rotate the turbine, which rotate the turbine. Therefore, we can able to provide the mechanical coil and magnet providing some relative movement. Relative movement it will be in terms of rotary movement. Therefore, power is generated. So here same thing it is available in the layout. Diesel engine is combustion ignition engine, what is called a CI engine. There are two-stroke cycle engine is more favored diesel power plant. Two-stroke. Air required to diesel engine is down through the air filter from the atmosphere combust inside the cylinder. Even for example, for two-wheeler also, air is important. Air is allowed. Air and the diesel put together, then finally giving that air which is coming out that we are allowing through the filter. The fuel from the diesel engine drawn the filter from all day tank and injected into the cylinder through fuel injector. Because of high temperature and pressure of the combustion air, the fuel ignite. Um, so this is the way the diesel power plant it will work. Next, I am coming to the hydraulic idle power plant. So, what is called a hydraulic power plant? So, you understand that in my prerequisite, I said the mechanical movement from the tire, which provides the relative movement. The mechanical in a rotation is given. Second one, coal is burned. Coal is burned. Then then the heat is converted into steam. Kinetic energy of the steam is utilized to run the power plant to generate the mechanical movement. Second one we have seen IC engine, the hot gas, right, while burning the diesel that gives the mechanical work. But here coming to idle power plant, this is there in people from AP, Sri Sailam power plant is there, no? Similar setup they are doing. So this hydroelectric power plant, it is constructed very near to the tank, water storage tank. That water storage, it will be there is a big tank will be there. That will be water tank. It is used to draw the drinking water and water for agricultural purpose. Every purpose they are releasing. So here the concept is very simple. We are storing the water in a huge tank, then later on what to do, suddenly if you open the water it will come with huge kinetic energy. That huge kinetic energy of the kinetic energy that gives the mechanical rotation, right? Mechanical rotation again, you go to old concept, we got the mechanical rotation within the magnet and the coil, right? That mechanical rotation that gives the uh, relative movement. According to Faraday's law of electromagnetic induction, the power will be generated. But here dynamo, it is very small device. You are running the tire with very uh, 20 kilometers per hour, that much slow speed. We can able to generate the very less power. Whereas in case of hydroelectric power plant, similar setup, but what happened? The water it will come with very huge kinetic energy. Therefore, you can able to generate up to many megawatts power plant. Just we will look at the layout of hydroelectric power plant. Here, water reservoir. Water reservoir means it is like a water tank. Here you have a gate. Here you look at the electrical energy. You have a powerhouse, right? Here you have a generator. From the generator, you will get the long distance power line. So original power generation it is happening here. So here the mechanical energy provision, providing mechanical energy is very important thing. The mechanical energy it is provided from the kinetic energy of the water. Let us explain. Here you have a reservoir this side. If you open the gate, then what happened? The water it will come through this penstock through very huge velocity. That the kinetic energy of the water is very high. Therefore, that rotate the turbine. That rotate the turbine. Therefore, here automatically you will get the mechanical energy. After rotating the turbine, the outlet water it is going and it is joined with the river. This water it is sent for drinking or agricultural purpose. Now we will go to the electrical energy generation. While rotating here, you have a generator. Generator means coil and magnet. So here we are providing the relative movement, the mechanical energy, the turbine rotation that gives the relative movement between the coil and magnet. Therefore, according to Faraday's law of electromagnetic induction, power is generated. The generated power it is tapped out and supplied through this line. This is the simple concept of hydroelectric power plant. Here it is the principle it is given. Potential energy is the energy in which the substance has due to its position and state. While storing the water, it will be with potential energy. Then the water behind the dam has a potential energy because of its position. The water can fall from this position, exert a force over the distance, therefore to do the work. In hydroelectric power plant, the force is used to drive the turbine, which in turn drives the electric generator. Because of gravity provides the force which makes the water falls. The energy stored in the water is called the gravitational potential. This you could understand if you are taking bath in some waterfalls, right? Waterfalls, it will be just flowing from just 10 feet or 15 feet height. Even if you go and standing under the water, uh, that water it will almost attack us. It will give a lot of kinetic energy, right? This is where a small passage of water it is giving force. Whereas if you open the tank, the water it will come up with very huge kinetic energy. So therefore, that kinetic energy it is helped to rotate the turbine. So here you look at another picture I am showing here. Just I want to show it's another layout. It is starts with the reservoir. You have a dam. You have a press rack. Here you have intake. Then you have a surge tank. right? Penstock, spillway, turbine, and power house. So this is called power house. Inside the power house, you have a transformer, and here you have a generation. These are all the power lines already given. Here you have a gate. So originally the water it is stored here. At the bottom, if you open the gate, the water it will flow through the penstock and rotate the turbine. After rotating the turbine, the outlet water it will go through outflow and it is going to the river. So now the because of kinetic energy, the turbine is rotated. The rotating turbine it will create the relative movement between the coil and magnet. According to the Faraday's law of electromagnetic induction, power is generated. That generated power it is we are supplying through the tap. So next I am coming to the nuclear power plant. Nuclear power plant, it's called atomic power plant. So nuclear power, atomic power plant, it is there with near Chennai, Kalpakkam. There is a place. This atomic power plant, it will be constructed very near to the ocean. So the nuclear power plant, we require more cooling, more water to cool the heat which is coming out from the atomic power plant. Therefore, if you are constructing the power plant very near to the ocean, they will take the ocean water and recirculate. Therefore, the heat will be nullified. Here, the concept is very simple. So, previously, thermal power plant burning the coal, and we got the steam. We rotated the turbine. Second one, diesel power plant. Diesel is burned, and we generated the high pressure hot gas. That is the working fluid that rotates the turbine and generated the power. Here, the heat is extracted from coal, heat is extracted from the diesel. Similarly, the heat is extracted from the nuclear reaction. You know very well, if you conduct a nuclear fission and fusion both reaction, the heat emission it will be very very huge. You know the atom bomb, everything. Uh, the heat is generated by using nuclear reaction. You know that nuclear reaction, more heat it will be emitted. That heat energy it is spent. That heat energy it is converted into steam, like coal power plant, thermal power plant. That kinetic energy of the steam it is used for generating the power. Similar concept. So here, how you are generating heat is the only difference when compared to diesel and coal power plant. Now you come to the theory. A nuclear power plant works in similar way as a thermal power plant. The difference between the two is fuel they use heat the water in the boiler, what is called steam generator. Inside the nuclear power station, energy is released by the nuclear fission reaction in the core reactor. Here, they are using the fuel, what is called uranium U-235, which produce as much as energy as the burning of 4,500 tons of high-grade variety of coal or 2,000 tons of oil. Okay, they are here. 1 kg of uranium, you look at how much calorific value it is giving, burning of 4,000 tons, right? So this will be somewhat uh, lesser volume. We can able to generate huge heat input, more power generation. But here, where like thermal power plant, diesel power plant, how the pollution is associated with here. Similarly, the nuclear radiation. So that nuclear fuel, the nuclear ash, it is deposited in land. If you are doing that radiation, it will be for several years. That gives a very big environmental problem to the human being. Uh, Next, I want to explain a simple the layout of nuclear power plant. Just I will come from left to right. So look at the reactor, what is called the containment structure. This is the nuclear reactor, right? Inside the nuclear reactor, you have a reactor vessel, you have a control rod. Control rod, it is made up of the cadmium material. You know the metal periodic block, it is there, cadmium. That a control rods used to control the nuclear fission reaction. The cadmium rod, what it will do is which avoid the neutron emission of neutron. That emission of neutron it will be absorbed by the cadmium rod. So therefore, further reaction it is controlled. So what is called the control rod? Control rod application is to control the reaction. Whenever you want to stop immediately, you just put the control rod inside so that the free neutrons, everything, it will be absorbed. Therefore, the neutron will not react with the uranium, will not generate heat. This is the simple concept. Here, heat is generated. Here, you have a pressurizer. So, pressure of the steam, heat is increased. Then, finally, here you have a turbine. Uh, Here, water it is coming here. Cooling water, water is circulating. So, heat is coming from nuclear fission reaction. Water is coming from this side. So, therefore, heat plus water, which generates the steam, right? Therefore, it is called a steam generator. The high pressure steam, it is circulated through the turbine. As usually the high pressure steam which rotates the turbine. Then from the rotated turbine, we are giving the relative moment between the magnet and coil. Power generated power, it is going to various buildings or something. So here once the steam which is coming out here, after coming here again what happened here, they are using some cooling jacket, cooling arrangements. Cold water it will come and it will take out the heat which is coming out from here. Again by using conductor, water is recirculated. So this is what the process of power generation through the nuclear fission reaction. Now we completed the power plant, right? Different power plants, steam power plant, diesel power plant, hydro power plant, nuclear power plant. So now we are going to talk about the mechanical power transmission. So power transmission, you will do through many process by using belt you can do, by using gear you can do. There are by using rope you can do. There are many ways. Power transmission means transmitting the power from one pulley to another pulley. This setup you can see in the floor mills. If you go for a wheat flour or a chili flour or anything, if you want to crush, there they will use. Okay, you have a driver pulley, driven pulley. The driver pulley is connected with the motor, right? Then power is transmitted to the driven pulley. So that here power they are putting a belt and transfer the energy from here. So this is rotating with the motor, right? Whenever switch on the motor, it will run. So now what happened? The belt which is connected with the driver pulley, which is moving. So therefore, the moving belt which rotate the driven pulley. Okay. If you carefully look at the floor mills, here you will get the slack side. Here the belt it will get little shake. Whereas tight side it will be more tight. There is no vibration. So this kind of things you might observe in the floor mill. That is a real time example to understand. Here you have a driver pulley, driven pulley. If you look at the top view, it will be like this, right? And normally flat belt they are using. Here you have a different dimension, right? You have a slack side driving pulley, tight side, slack side, right? This is the basic structure of the belt drive. Whereas if you look at the chain drive, you have a nomination. Chain means this is the typical arrangement you will see at the bicycle, all the two-wheelers, right? Here, what normally what we will do is, if you take bicycle, here you have a pedal. If you press the pedal, through pressing the pedal, we are rotating this gear. We are rotating this gear. So through chain, the whatever power generated that will be transmitted here. This back wheel. From the back wheel, what happened? Your tire is rotating. Otherwise, you take a two-wheeler. We are giving power instead of giving manual power. Here, by using IC engine, power is generated. They are giving rotary movement. Rotary movement. That power generated here, what is called a driver pulley, through chain, they are rotating. If you take the chain, you have some nomenclature you have. It is the distance between the center to adjacent pin. It is center to center distance. Or pitch circle diameter, it is available here. It is a distance between the pin center and center of this bracket. If you look at the animations, you have the driver pulley, driven pulley. Sometimes you will have some intermediate gear also, right? It is a single chain. Sometimes you will have a multiple chains also. Next, I am coming to rope drive. So the rope drive, I think you can seal that some well to take the water out. Right at my school days, I have seen this kind of taking water from the well by using the rope. Right, here you have a pulley, putting the rope into the pulley, and we are pulling. When compared to conventional way of taking, this one we can reduce the effort. The rope drive is widely used for large amount of power is transmitted from the pulley to another over considerable distance. Considerable distance means that pulley to well depth. So almost, for example, 30 feet, 40 feet depth will take a water. So I could remember my school days, almost 30, 35 feet, we will get the water level, it will be that level. We will tie a bucket into the rope and we will put it into the well. Then finally, if you are pulling, when compared to without pulley, if you want to pull the water, it is very difficult. At the same time, the rope will tear. Whereas if you are using this pulley setup, the effort will be reduced, the rope life it will be more. You can smoothly take the water out from the well. So it may be noted that use of felt welder is limited for only transmission of moderate power. For example, less power means like your floor mills or somewhere it is easy. Whereas if you want to use a very large load, if you want to pull out, this is the better source. If large amount of power to be transmitted in flat belt, it would result in excessive belt cross section. More thickness belt they will use and they will do. The rope drives you have two types. One is fiber ropes, another one is wire rope. Fiber rope, it is there. You can see almost all the well. And the wire rope, you can see at the construction site. They will use the wire rope instead of this. Fire rope means the problem is by fiber it is made up of coconut fiber. It is a biodegradable one. If you are buying new rope and keeping for 1 year or 2 year, automatically it will get biodegraded. If you are using biodegradable rope, then what happen? It will wire well rope will cut down and it will create some accidents. Next, I am coming to gear drive. So gear drive you can see at lathe or your gearbox. It may be a two-wheeler or a four-wheeler. The power is transmitted through the gearbox. You just understand what is the need for a gearbox in two-wheeler. If gearbox is not there, you will go with the unit speed, right? You can't. For example, if you are putting first gear, you will get more power and you will ride. Second gear, third gear, it will help you to go for somewhat faster. Here you have a N2 by N1 equal to D1 by D2. That means diameter reduces, yeah, RPM will increase. So this is the basic concept. Let us take a gear drive, power transmission from movement of energy from its place of generation location and applied to performing the useful work. Better you can take the example of the two-wheeler or four-wheeler unit. The gear is a component within a transmission device that transmits a rotational force to the another gear drive. Here you have different types of gear. Different types of gear means different arrangements. You have a fur gear. This kind of fur gear you have seen in automobile gearbox. You have a helical gear. Helical gear means the teeth it will be with some angle. That angle is called the helix angle. And here you have a rack and pinion. So here two gears are there. Instead of one gear, you will have a rectangular rack, right? If you want to get rotary to linear or linear to rotary, this is very easy. What is called a gear rack. Sometimes it is called as a rack and pinion gear. So this is called a bevel gear. If you want to transmit the power into 90 degree, for example, your gear is rotating with the horizontal axis. If you want to transfer the horizontal into vertical, you can use bevel gear. Okay. For example, automobile rear wheel, you will have this, right? You will get the bevel gear to transmit the power to two back wheels. And similarly, meter gears, 90 degree, and you have a worm gear. One is gear and another one is like a worm. Then you have a screw gear. Apart from that, you have a internal gears. You have many gears are there. Coming to application of gear drive in a car, first motor turns the shaft which is attached to the gears, so that gears also start to turn one after the another. Gradually, this turning process come from one gear to another. When the last gear start to turn, which is attached with the car axle, and rear axle start to move. So that rear axle means back wheel, right? The power is generated at the front. Where you take any car engine, it will be at the front. From front to back, the power is transmitted, so that the power it will be given to the back wheel. As a result, the wheel of the car start to move. This is how gear system moves the car. Similarly, two-wheeler also similar setup is there. And now the second half of the unit is over. Now I am going to again syllabus page. Uh, Now power plant completed, mechanical power transmission completed. Now I am going to talk about the robotics. So robotic, I will start from the basic. What is meant by a robot? A robot is called, I think you can see the pictures. You have an industry robot, you have a small robot, it's a mobile robot, and it is another robot, it's look like a humanoid one. And other robots, it is used to, uh, like this is like a Scorpio, right? Even nowadays, you got the mini robot also. It will fly on the air, right? First of all, I will explain the definition. Definition for robot is a reprogrammable, multifunctional manipulator designed to move material or parts, tools, or specialized device through various programmed motion for the performed variety of tasks. This definition is given by Robot Institute of America at 1979. Given in dictionary definition, if you take robot is called automatic device that performs the function normally ascribed to human or machine in the form of human. The word robotics refers the study and use of robot. The term it is used from the Russian-born American scientist, the writer of Asimov, Isaac Asimov. Like in, so he is the father of robotics. He developed some law. Still, we are studying. So just to come to small history of robot, brief history of robot. Robot was created by Karel Čapek. Is a Czech playwright, and the word forced labor or such word robo means forced labor. It is a use of that word robot is introduced to play RUR. That means Rosum Universal Robot, which is opened Paraguay in 1921. You may find it interesting to note that robot it was wrote about more mechanical nature, but were created through the chemical means. In an essay written 1935, Chepak strongly argued that this idea was very possible. Difference between robot and automation. So here robot means automation means we are using robot and automating the manufacturing system. Just automation, automating industrial process involve controlling and supervising the physical procedures. Whereas robot refers to automating the process within the industry using the physical machine or control framework. This is the basic difference between robot and automation. So next we will go to the robot law. Isaac Asimov, three laws of robotics. These laws are developed at 1940. Here, first law, second law, third law, you should not look at the English. Okay, this is the translated from Russian. So therefore, there is some lapse in English, but we have to understand the physical meaning of the law. A robot may not injure a human, or human through inaction allow human to come to harm. Whatever robot you developed should not against the human. That is important. The first law already proved by the recent Robo movie. The famous actor Rajini he acted Robo Part One, Part Two. Right? If there finally what happened? If you are misusing the robo, it will injure the human. Right? It become harm to the human being because of wrong programming or putting a wrong chip into the robot, how it become harm to the human being. That one we have physically witnessed, right? If you go against that is a violation of first law, you will get raised. A robot must obey the orders given by the human being. This is very important. A robot should be controllable by human being. It should not go out of human being. If it goes out of human being, that will turn against the human. The third law, robot must protect its own existence as long as such protection does not conflict with the first law or second law. Here, third law, what they are trying to say is wherever robot is required, you can use. Otherwise, it is not required. For example, typical example, wherever there is no safety for the human during their work, you can use robot. Otherwise, it is not required. So, for a typical example, recently Uttarakhand there is an accident. There is around 40 people, 40 workers. They are drilling the rock and going for road construction or something. They are doing. They are drilling the rock and going inside. Suddenly, what happened? Some portion of the rock it is broken and blocked their path. So all the 41 the people workers they are inside. Almost people they struggled for more than 10 days, and finally they carefully recovered. Right? If they are employing human, we have this problem. 11 days the whole media it is focused. Suppose if you are employing robot, this kind of risky work, uh, it is better. So that's what here they are saying. Wherever robot is required, huge risk for human doing the work. There is no problem to employ the robot. Otherwise, employing robot it is against country like our India, because India you have more manpower, right? If you are employing robot, that create unemployment. So this is the progressive advancement in robot. So here the detailed description is here, but I want to teach only this. The first generation progressive advancement, first generation robot, it is like it is used for repeating task, because repeated work, people they will get the um, what is called tardiness. Therefore, they will do some work. They will do mistake. That mistake it which reflects in the quality, something like that, and is used in pick and place or point to point. In present, 80% of robot in this kind at 1960, whereas at 1980 they are adding of sensitive sensing devices. You are putting sensor, path control capabilities they given. Previously, robot it is used just like a machine. Here they are putting at 1980 they are putting some sensor. It's like 50% of human. In third generation they are using different. They are integrating artificial vision. They are giving artificial vision, putting camera. That camera it will be like eye, like that it is going. And third generation robot it will interact with the environment. That will study the environment and it will give a report to us at 1992. Now, fourth generation, the true android and artificial biological robot, what is called humanoid robot, superhumanoid capable it one clones or 2020, 2000 they are using. They are using humanoid robot. It will be almost like a human, like that movie shown, no, Robo movie, what they are showing. Same thing. Generation of humanoid robo. That robo, it will work like a human that is completely controlled by the program. So this discussion I'm leaving to you. Anyway, I'm going to sharing the PowerPoint slide along with this video. I think you will follow it. Here we have to look at the progressive development of the robot. Just I want to give a glance. Previously, the manual, no robot is involved. Later on, they are putting the pre-programming. Here, what they will do is human will plan the work, robot will execute the plan, right? Robot will execute. Coming to adaptive manipulation, human will plan the work, robot adapt to plan. Robot is adapted to plan the work and do the work. And imitation learning, plan work and robot learn and execute. Robot learn from the human and execute. Then improvisatory control, human monitor and improvise work. And robot it will plan and execute. Look at here, robot everything it will be work. Here first time robot it will plan and execute the work. Only human they are taking information about the work. Then robot will plan and execute both work. It will be taken care. Here coming to full autonomy robot, this is called humanoid robot. Human role is just monitor. Robot it will do the plan and execute. You take some Fanu company. Fanu company means that the company it is located at the Fiji Island. They are manufacturing lot of heavy machineries. Their complete robo it is planning. Once if they are getting the order, robo will plan and draw the raw material and do the manufacturing and delivering into the loading and delivering into the vehicle. Up to that, robo it is taking care of planning, manufacturing, and planning, manufacturing, and delivering into that load vehicle. Up to that, robot it is taking care. Next, coming to the robot anatomy. Anatomy means it's like a human body, human anatomy. right? You can compare the robot anatomy with the human anatomy. Human anatomy, this portion is called the waist, shoulder, elbow, wrist, tool. This is almost like a palm and finger arrangement. Here you have a wrist, like our human. This is a elbow, this is a shoulder, this is a waist. Waist means that the hip, right? Similar thing, you have, it is with the robot anatomy also, it is there. Here, assembly of body, arm, wrist, it is called as a manipulator. So here, by using that, the arm, it will rotate or it will swing, right? It will take a linear movement, rotary movement, almost all the movement, it is possible. Coming to robot anatomy, this is the robot anatomy. Here they are telling manipulator. This portion of the robot it is called end effector, like form finger arrangement. Here manipulator joints and links. Manipulator, it will be a robo. You take that link one, link two, link one, link two. It is connected with joint one. Sorry, joint two. Similarly, link two, link three. It is connected at the joint three. So end of the arm, you have a end effector. So then work will be completed. So here, the most of the robot possess 5 or 6 degrees of freedom. Degrees of freedom means almost the possible way of movement. For example, if you take robot, it will take movement from right to left, front and back, up and down. So linear six movement. Similarly, rotary, rotation about x-axis, rotate about y-axis, rotate about z-axis. Next, I am coming to the classification of robot. It is a classification. It is based on the degrees of freedom. If it is more degrees of freedom is given, some robot it is like five is at least required, six is mandatory. Anything less than six, it is called redundant or deficient robot. Then kinematic structure, open loop, parallel, and hybrid. So open loop, the rigidity it will be less when compared to parallel. But a hybrid manipulator, it is used at industrial robot because industrial robot it is a heavy duty one. Next, I am coming to the drive technology. What kind of power source you are using? Whether you are using electrical energy, using hydraulic energy, or pneumatic energy. And again, workplace geometry, you have a Cartesian, cylindrical, spherical, articulated, scalar robot. This is the basic geometry. This one we are going to discuss in detail. Then motion, you have a planar or planar means linear movement, spherical manipulator and a spatial manipulator. Here the classification already, here itself I clearly discussed. Same thing you can refer. Next, you come to the degrees of freedom. Degrees of freedom, already I said, six linear movement, six rotary movement like this. For example, you take this particular setup. This is called a pitch. The axis is horizontal. Yaw means vertical. Then roll is with respect to uh, different direction. For example, this is x. If you take this is x, pitch is x, yaw is y, roll is z. With respect to z axis, it will rotate. Here, the pitch it will take care up and down movement. For example, pitch it is there. It will take the whole body. It will take a up and down movement. Here you can look at. Then yaw means this particular point. It will take right to left movement. For example, this particular one, it will take right or left. Then roll, it will take care only the rotary movement. So here previously we have seen robot, you have a polar, a cylindrical and Cartesian. Cartesian, you have a, there is no rotary movement, only you have a linear movement. X direction, X plus X minus, Y plus Y minus, Z plus Z minus. Whereas if you take a cylindrical robot, the work volume it will be like this cylinder. Whereas if you take a polar one, you will get a spherical shape. Not complete spherical, some place you have little open. Next, we go to the important configuration of robot. You have a Cartesian, cylindrical robot, polar or spherical robot, scalar robot, angular robot. For there are five configuration. Cartesian, only linear movement. There is no rotary movement. Here two linear, one rotary. Here two rotary, one linear. And here also two rotary, one linear. Here you will get an angular movement also. Here some people you will have a clarity required on SCARA, SCEA, SCARA acronyms means Selective Compliance Assembly Robotic Arm. This is used for assembly purpose. Coming to the first robot configuration, you will get a X, Y, Z. There is no rotary movement. The work volume, it will be like a cylinder, what is called Cartesian. Here, there is no rotary movement. If you come to cylindrical one, right, with respect to z-axis, it will make a rotation. It make a up and down movement. This make a right and left movement. The work volume, it will be like a cylinder. Coming to this, this is a spherical one. Here, this will have a front and back movement, linear movement. This is a rotary movement. So whole structure it will rotate with respect to this. And again, this portion it will swing above and below. This is called spherical. The work volume it will be like a spherical one. If you take a articulated robot, it provides the angular movements also. You will get a rotary movement with respect to this side and this side. And this is the selective compliance assembly robot, what is called a SCARA robot. It is widely used for assembly. Here you have two rotary movement and one linear movement. This one I will explain this will be like a drilling machine, right? A drilling machine. So while discussing about unit 2, I will explain. Coming to robot specification, if you want to buy a robot, some parameters are important. Some is for industry robot, some is for other robot. So you see, robot it is used for different applications. Starts from industry. They are using in hotel. Robot will act as a bearer, many things. Here, robot specification, you have a joint variable, end effector, degrees of freedom, configuration. So we discussed the five, which one is configuration space, whether you want to rectangular cylinder, workspace, accuracy, speed, acceleration, payload capacity. These are all the basic specification of the robot. If you go for industry robot specification, number of axes, this is important. How many rotation, how many linear, what is the payload, what is the repeatability, precision, accuracy, what is the speed of the robot. These are all the important specification for the robot. Next, if you want to talk about end effector means that is the that after the rest, whatever position available. So end effector, you have two things. One is the end of the robotic it is called end effector. There are two things. Once you have a gripper tool, you can use for different purpose. The robot end effector, it is a device attached to the rest of the manipulator. Coming to the classification of end effector, you have a mechanical finger, special tools, universal finger, or you have a single gripper mounted on wrist, multiple gripper mounted on wrist. The end effector, if you are using tool as end effector, you can give the welding tool like spot welding, arc welding. Even you will give your robot you can use for drilling and grinding. You can give a machining. Drilling and grinding is the machining process. Spot welding, arc welding, these are all the welding process. Apart from that, robot can be used for spray painting. For example, this is the typical application. We are using the gripper, end effector as a gripper. You look at the different orientation of the gripper, you can able to grip the component. For example, if you want to employ the robot as a drilling machine, this is the robo end effector. They are putting the drill gun. Therefore, robo is getting drilled. Here you look at the robo end effector. They are connected with the arc welding. So robo it is doing the welding. Reason for using robo for welding process. During welding process, lot of harmful radiations are emitted. Therefore, human cannot do. So therefore, they are employing the robot. So this is another robot. It is used for spot welding. Look at the automobile structure. Automobile structure. It is made up of the thin sheets, right? So therefore, the thin sheets. If you are using robo, then only you will get the quality of welding. Otherwise, if you are employing human, the weld quality it will not be inaccurate. Sometimes weld joint strength it will be very less. Some if you are giving little extra time, the weld bit it will spoil the plate also. Therefore, weld rigidity it will be reduced. And robot it is used for using painting of car by a spray painting. So paint is important. The car color is important feature to attract the customer. Therefore, the painting and the quality of painting. If paint is evenly distributed throughout the car, that would be beautiful. Otherwise, if it is paint quality is not good, that consistency is not good, the thickness is not good, that will not attract the customer. Therefore, they are painting work. They are using the robo. So apart from that, robo as a gripper, it is you can use different types of gripper. For cylindrical component, you can hold like this, or if you have a rectangular jobs, you can grip like this. Suppose your component is like a circular blank or something, you can grip like this, right? This is called encompassing grip, parallel grip. Here, just I am showing how robot is used in spot welding. Already I discussed in the automobile example. So this is the spot welding process. Just I am providing the text to you, right? Here, important component is welding gun, weld controller, and spot sealing. So here we have to supply the heat uniformly and holding time. These two controlling manual, if you are employing the manual labor, they will do a lot of mistakes. Sometimes they are giving, if they are giving lesser timing, joint strength will be poor. If they are giving excess timing, that will burn the plate. So therefore joint rigidity of the structure, it will get loosened. Because of this problem, robo is employed. And coming to the advantage and application of the robot eliminate the workload of operator, cost handling, heavy welding guns, improved quality is achieved through consistency, better repeatability of location of weld, improved safety by removing human work environment, therefore hazardous from electrical shock, burning, this can be avoided. Complex welding profile can be welded easily where manual welding is difficult. Improved productivity, improved cost effectiveness, less wasted material, good ROI, return on investment. Here the application of robotic spot welding, here already I given. It is automotive industry, it is widely used. It because of application of robot spot welding is good example of cost justified application and relieves the human from the tedious and difficult hazardous job. Next, I am coming to the gripper. Gripper means it is a previously I discussed, and I want to how to operate the gripper. You have a mechanical, hook, scopes, magnetic, vacuum, and expandable adhesive gripper. Mechanical gripper means it will be like this. They are using mechanical energy. Here we are applying force, then which control this mechanical link, and finally you will get a gripper. This is you can understand from the bicycle brake. It is the mechanical gripper. Just apply the press the brake, then that power is transmitted through multiple link. Finally, the brake shoe it will make a contact with the rotating rim, and your vehicle is getting stopped. Mechanical gripper, you have two methods using finger pad like a shape of fork bar, or you can use soft material finger pads. So these are all the two ways. And coming to hooks and scoop means it will be like a gripper. For example, here end effector you have two gripper. Based on the component, this will expand and it will cover. The V-shaped teeth it will help you to hold different shapes, right? So this is a one robot. It is operated with the vacuum. This is called the hooks and scoops design. Coming to magnetic gripper, even they are using magnet to grip the robot. If you use niobium and other electrical magnets, easily you can control. Just to place the component over the workpiece, just you give the electrical power, so that therefore electrical magnet get magnetized and grip the workpiece. But the limitation for magnetic gripper, you will get very good gripping force. There is no issue. But the problem is your material should be a ferrous one. Non-ferrous material, the magnet will not attract. Next, coming to suction gripper. Suction gripper means vacuum gripper. By using vacuum, they are sucking and holding. Here you look at the vacuum pump, right? They are sucking the air. How two cotton boxes are gripped by the vacuum gripper. This is they are using vacuum to grip the workpieces. Next, expandable means this is they are using extendable bladder material. For example, if you have any hole, just insert through this hole, and if you supply the air, this will expand while lifting. This will not remove from the hole. This is called expandable bladder type gripper. Bladder means expandable material. And adhesive gripper means it's like adhesive means it is the it will be like a gum, right? Like Fevicol, Araldate, Fevikwik, this kind of material. Look at the typical example I want to show in the picture. Here, yeah, adhesive gripper pen is pasted with the robotic arm, robotic end effector. Through programmed movement, the robot it is drawing the diagram. Another one, you look at the robotic arm by using adhesive gripper. It is taking a glass with water and it is uniformly pouring, right? So these are all the various types of grippers. Yeah, with this, I conclude my lecture. So I hope this video is very useful to you, and I am sharing the PowerPoint slides also. Therefore, it will help you to better understanding the subject. Thank you all.